अस्सलाम वालेकुम डियर स्टूडेंट्स, मैं हूं इशफाक रियाज और आज हमने फिजिक्स का एक इंटरेस्टिंग और इम्पॉर्टेंट टॉपिक आपके लिए चुना है। टॉप चैप्टर का नाम है ऑप्टिक्स एंड टॉपिक इज रिफ्लेक्शन ऑफ लाइट। सो इट डील्स विद द लाइट। सो बिफोर डिस्कसिंग ऑप्टिक्स, व्हाट इज ऑप्टिक्स, रे ऑप्टिक्स एंड द वेव और द क्वांटम ऑप्टिक्स, लेट अस डिस्कस लाइट and the nature of the light first. So you might have heard this word in the previous classes as well. So you can see the light from the luminous sources like your sun, your stars, your bulb. We have the Fresnel light here. Like you can see the light from the candle as well. That is the emitting light, the luminous object. So what is light basically from physics point of view? It is simply a form of energy which gives us the sensation of sight, I can say. So light from physics point of view, we define it, it is simply a form of energy which gives us the sensation of sight, or I can say sensation of vision, or simply I can say which makes things visible to our eyes. Right? So this is the basic definition of light from physics point of view. It is simply a form of energy. Just like heat is form of energy, sound is also a form of energy. Same is the case with the light. It is also a form of energy which gives sensation of sight, sensation of vision, and makes things visible to our eyes. Right? Okay, let us discuss two important facts about light first. The first fact is light always travels in a straight line. That is called the rectilinear propagation of light. So rectilinear propagation of light. Now what is a rectilinear propagation of light? That light travels in a straight line. You might have verified this, how light travels in a straight line in previous classes as well. That if I place a source of light here and an opaque object here, it casts a sharp shadow of it. This basically confirms that light travels in a straight line. And the second fact regarding the light is that it travels with the enormous speed which is equal to the 3 into 10 raised power 8 meter per second. Light in vacuum travels with the enormous speed, and this speed, I mean 3 into 10 raised power 8 meter per second, this is the absolute constant of universe. It travels with this highest velocity, and this velocity is the highest achievable or highest attainable speed in the nature. So two factors about light are that it travels in a straight line, that is called the rectilinear propagation of light. I will come to the diffraction of light as well. Now the speed of light in vacuum and all other electromagnetic waves, it is 3 into 10 raised power 8 meter per second, which is the highest achievable speed in nature. So these are two factors regarding the light. Now what about this light? What about the nature of the light? Is it a particle or a wave? This was basically controversial for hundreds of years. That is light a particle or a wave? So many theories were given in this regard by different scientists. So let me write here nature of the light, because we have to deal with the optics. That is basically the branch of physics. I will come to that optics as well. So let us discuss the nature of the light first. So let me write here nature of the light. Is light a particle or a wave? Many theories were given in this regard, that is whether light is a particle or wave or both. So first of all, the corpuscular theory was given by Isaac Newton. So let me write here corpuscular theory. This was given by Isaac Newton regarding the nature of the light. So as per the corpuscular theory, light consists of extremely small lightweight material particles. Dear students, this basically confirms the particle nature of the light. So as per the corpuscular theory, light consists of extremely small lightweight material particles. जिनको न्यूटन ने नाम रखा corpuscles, material particles, and those particles were called the corpuscles, right? So that is why this theory is called the corpuscular, rather Newton's corpuscular theory. So as per the corpuscular theory, light consists of extremely small lightweight material particles जिनको हम corpuscles कहते हैं. But this corpuscular theory could explain only, I will say, 3 R's. What are those 3 R's? One R is rectilinear propagation of light, that is light travels in a straight line. Another is reflection of light, that we are going to discuss in this very chapter in detail, in this topic in detail. And another R is refraction of light. So this theory, I mean the Newton's corpuscular theory, could explain only rectilinear propagation of light, reflection of light and refraction of the light, but this theory failed to explain interference of light, that is basically a wave phenomenon, interference of light, diffraction of light, because light also bends around the corners of an obstacle, and the third phenomenon, that is polarization of light, that is again a wave phenomenon. So this theory, I mean the Newton's corpuscular theory, failed to explain interference of light, diffraction of light and polarization of light. Later, after this Newton's corpuscular theory, another theory was given by Christian Huygens. So that is called the Huygens wave theory. So let me write here wave theory of light. So it was given by Christian Huygens. So wave theory of light given by Christian Huygens. Alright. Now, as per the wave theory of light, as per Christian Huygens, light is a wave which propagates through hypothetical medium, और इस medium को ह्यूजन ने नाम रखा luminiferous ether. So as per the wave theory, light is a wave which propagates through hypothetical medium called ether. Now, from the previous classes we know velocity of a wave, it is given by under root of E divided by rho, where E is the elasticity of the medium and rho is the density of the medium. Now, to explain the high velocity of light, that is, see, as I said earlier, it is 3 into 10 raised power 8 meter per second. To explain the high value of velocity of light, this ether, luminiferous ether, medium ether, must have high elasticity and low density. I mean, this medium ether must have high elasticity and low density, but remember dear students, these two properties contradict each other. So he could not explain the high value of velocity of light in vacuum, right? And also he could not explain the existence of the medium ether that does not exist, right? So he could not explain, although as per this theory light is a wave, but he could not explain the existence of the medium ether and the high value of velocity of light in vacuum. After Christian Huygens, another scientist came who gave the electromagnetic theory of light. So let me write here the electromagnetic theory. So electromagnetic theory. Electromagnetic theory. This theory was given by James Clerk Maxwell. So as per Maxwell, light is an electromagnetic wave, rather electromagnetic transverse wave. As per this James Clerk Maxwell, light is an electromagnetic transverse wave. Now what is electromagnetic wave? As per Maxwell, light wave consists of both electric field as well as the magnetic field, and they are perpendicular to each other and to the direction of propagation of wave. So let this be electric field denoted by E vector, and let this be magnetic field denoted by B vector, and the wave is perpendicular to both E and B. So what is an electromagnetic wave? Electromagnetic wave simply consists of electric field as well as the magnetic field at right angles to each other. Let me write here, at right angles to each other and to the direction of propagation of wave, or simply you can remember this electromagnetic wave does not require any material medium for its propagation. So the direction of this electromagnetic wave, it is given by the cross product of E and B. So this is E cross B, which represents the direction of electromagnetic wave. So as per Maxwell, light is an electromagnetic transverse wave. So this was the electromagnetic theory of light given by James Clerk Maxwell. उसके बाद एक और साइंटिस्ट आया, namely Thomas Young. He explained the interference of light, which is again a wave phenomenon. So interference of light, it was explained by Thomas Young in his famous experiment called Young's डबल स्लिट एक्सपेरिमेंट. ये भी सिलेबस में ही है 12th क्लास में. यंग्स डबल स्लिट एक्सपेरिमेंट which was performed in 1802. So this Thomas Young rather explained the interference of light, which is again a wave phenomenon, right? Later on came two more scientists, namely Fresnel and Fraunhofer. Fresnel and Fraunhofer. Fresnel and Fraunhofer, who explained one more wave phenomenon called the diffraction of light around 1815. So diffraction of light, as I said earlier, light travels in a straight line, but remember dear students, it bends around the corners of an obstacle. That bending of light around the corners of an obstacle is called the diffraction, which is again a wave phenomenon, which was explained by Fresnel and Fraunhofer, right? After this, Max Planck gave the Planck's quantum theory. आपने नाम सुना होगा Planck's quantum theory का. So let me write here Planck's quantum theory. We are basically studying the nature of the light. Is light a particle or a wave? So different theories were given in this regard by many scientists which we are discussing here. So let me write here Planck's quantum theory given by Max Planck around 1900. So as per the Planck's quantum theory, light wave consists of tiny bundles of energy or beam of energy, or I can say packet of energy, and that beam of energy, bundle of energy, is called the quanta, right? Or you can say photon. So photon is basically the elementary particle of light. So as per Max Planck, the light wave consists of tiny bundles of energy, or I can say tiny packets of energy called the quanta or photon, and the energy associated with each photon depends upon its frequency as per the relation E is equal to h nu. This is called the Planck's quantum equation basically. So E is the energy associated with a wave associated with a photon or a quanta, nu is the frequency of the wave, and h is Planck's constant, and this Planck's constant is equal to 6.6 into 10 raised power minus 34 joule second. This is the value of this Planck's constant. So as per Planck's quantum theory, E is equal to h nu. Light consists of tiny bundles of energy called quanta or photon. And remember dear students, this Planck's quantum equation E is equal to h nu quantum theory, it was used by Albert Einstein to explain the photoelectric effect. This was used by Albert Einstein to explain photoelectric effect, which this photoelectric effect again confirms the photon, the quantum, the particle nature of the light, right? So some of the properties of the light can be explained by particle nature, like we observed reflection of light, refraction of light, rectilinear propagation of light, casting of shadows, and some of the properties of the light can be explained by wave nature, like interference of light, diffraction of light, and polarization of light. That is why it was said that light possesses both the particle as well as the wave nature. Particle as well as the wave nature. And in physics we say that light possesses dual nature. So basically light behaves both particle as well as wave. So that is why we say that light has a dual nature. Later on, this concept of dual nature of light or dual nature of radiation, it was extended to matter as well by scientist namely Louis de Broglie. So let me write here, Louis de Broglie around 1924 extended the concept of dual nature of radiation, dual nature of light to any matter in the universe. Whenever a particle is in motion, waves are associated with that, and those waves are called the matter waves. So matter waves, and the wavelength of the matter waves is given by lambda, it is equal to h divided by mv. This is the wavelength associated. Lambda is equal to h divided by p, or you can say where p is the linear momentum, or that is equal to mass into velocity. Whenever a particle is in motion, waves are associated with it. Those waves are called the matter waves or de Broglie waves, and the wavelength associated with the de Broglie waves is given by lambda is equal to h divided by mv. खैर ये तो एक अलग सा चैप्टर है, dual nature of matter and radiation. I will not discuss the dual nature of matter here, but dual nature of radiation. So light, the nature of the light is now it possesses dual nature, that is it behaves both particle as well as wave. So light has dual nature. Now the branch of physics which deals with the study of nature of the light. So we discussed the nature of the light. The branch of physics which deals with the study of nature of the light, sources of the light, we can have luminous sources of the light, sources of the light, then properties of the light. We have different properties of the light like reflection of light, refraction of light, dispersion of light, interference, diffraction and polarization of the light, and different optical instruments. In optical instruments we have eye, that is also an optical instrument, right? We have different optical instruments like eye, camera, microscope. You can have simple microscope or compound microscope, and telescope, astronomical or terrestrial telescope. So the branch of physics which deals with the study of nature of the light. Right now we know the nature of the light, it possesses dual nature. Sources of the light, we have different luminous sources of the light, and properties of the light like reflection of light, refraction, rectilinear propagation, dispersion of the light, interference, diffraction and polarization of the light, and different optical instruments. We have eye, we have camera, we have microscope, different types of the microscope, and telescope. That branch of physics is called the optics, right? So optics is basically the branch of physics which deals with the study of properties of light, nature of the light, sources of the light, and different optical instruments. And remember dear students, we have two branches of the optics as well. One is the ray optics and another is wave optics. So this is ray optics, and the another branch of optics is basically the wave optics. Also this ray optics is called the geometrical optics, and this wave optics is called the physical optics, right? Now in ray optics we treat light to be propagating as in the form of rays. So light is treated as just like it propagates in the form of rays, and this ray optics, it is valid only if the wavelength of light is very much less than the size of the obstacle, right? So in the ray optics basically what we study are some properties of the light like reflection, refraction, rectilinear propagation of light. And remember dear students, the working of all the optical instruments is based upon the ray optics, right? And in wave optics basically this physical optics we divided into two branches. One is the wave optics and another is quantum optics, right? So one is wave optics and another is quantum optics. In wave optics what we explain are some of the phenomena like interference of light, as I said earlier, wave properties, diffraction of light and polarization of light in wave optics. And in quantum optics what we explain are some of the phenomena like we explain photoelectric effect. As I said earlier, this photoelectric effect was explained by Albert Einstein on the basis of E equal to h nu. So this photoelectric effect that confirms the quantum nature of the light. So photoelectric effect, we have black body radiation, like we have Raman effect, we have Compton effect, and the working of laser, light amplification by stimulated emission of radiation. We have Raman effect, we have Compton effect, and the working of laser. These are basically explained in a branch of optics that is called the quantum optics. So dear students, let me remind you, we have two branches of the optics. One is ray optics or geometrical optics, another is physical optics, is basically divided into wave optics and quantum optics. In ray optics, we basically study the particle properties of the light, usually like reflection, refraction and rectilinear propagation of light, and this ray optics is valid only if the wavelength of light is very much less than the size of the obstacle. And in wave optics, we basically discuss interference of light, diffraction of light and polarization of light, which are the wave phenomenon. And in quantum optics, we explain phenomena like photoelectric effect, black body radiation, Raman effect, Compton effect and the working of laser, right? So these were two branches of the optics, right? Now let's have a brief review about the light. Right now you know light is an electromagnetic wave. It does not require any material medium for its propagation, and the velocity of light in vacuum is 3 into 10 raised power 8 meter per second. And remember dear students, the velocity of light and all other electromagnetic waves, it is different in different media. I mean, the velocity of light changes when a medium is changed, and this is the velocity of light in vacuum, right? So light is an electromagnetic transverse wave. Why transverse wave? Because it can be polarized. That is why we say light is an electromagnetic transverse wave. And the wavelength of this visible region, you might have heard this word waveguide. The wavelength of this visible region, it ranges from 4000 angstrom to 7800 angstrom, or you can say 400 nanometer to 780 nanometer. You can also convert it into meters as well. And the elementary particle of the light is called the photon, right? And you know light travels in a straight line, that is called the rectilinear propagation of light. You can easily verify this fact as well. And the last property, as I said earlier, light bends around the corners of an obstacle. That phenomenon in physics is called the diffraction. This is basically the wave phenomenon. Now, as I said earlier, the elementary particle of the light is called the photon, and this photon is electrically neutral. That is, it is not deflected by electric field and magnetic field. So this was the brief review of the light. Now let us discuss the first property of the light, first topic in this very chapter, optics, that is the reflection of the light. So let us discuss reflection of the light here. Now see, let me have a surface here. Now, when a ray of light falls on the surface of an object, three cases arise. Case first, it may be absorbed. If it is absorbed completely, the body will appear black. Such a body is called a black body, and I am not going to discuss this very case here. Case first. Number two, and if a ray of light falls on the surface of the object, it may be transmitted. If it is transmitted, then this object must be transparent. Case third, if a ray of light falls on the surface of an object, it may be sent back into the same medium. बात समझ आ रही है ना? When a ray of light falls on the surface of an object, three cases arise. Number one, it may be absorbed. I discussed the case of black body with you. It may be transmitted if the object is transparent. And number third case, it may be sent back into the same medium. This is our case, this case we are going to discuss here. This sending back of light into the same medium, this process, this property of the light is called the reflection of the light. बात समझ आ रही है ना? Sending back of light into the same medium. So let me write the definition of a reflection of light here. This sending back of light into the same medium is called the reflection of light, or I can say this bouncing back of light, because light bounces just like a tennis ball into the same medium. This bouncing back of light into the same medium, it is also called the reflection of light. और एक और definition मैं बताना चाहूँगा, the phenomenon of change in the path of light, because light changes its path, but remember here medium does not change. If medium changes and light changes the path, that light bends, that property is called the refraction. Now, the change in the path of light without any change in medium. So let me write here, change in the path of light, change in the path of light without any change in medium. Change in the path of light without any change in medium. Without any change in medium, this phenomenon is called the reflection of the light. So this case, sending back of light, bouncing back of light, or change in the path of light without any change in medium, it is called the reflection of the light, right? So this is the basic definition of reflection of the light. And now let us discuss two types of reflection. One is regular reflection and another is irregular reflection. So let me write here types of reflection, right? So number first is regular reflection. We also call it specular reflection. So let me write regular reflection here, or we also call it the specular reflection. Now what is regular reflection? Let me elaborate it on a diagram, right? Suppose if the reflecting surface is smooth and well polished, if the reflecting surface is smooth and well polished, do you remember the smooth and well polished surface? Usually in physics we take the plane mirror, ordinary plane mirror basically. So if the reflecting surface is smooth and well polished, and if I throw some light on it, the rays of light which are parallel to each other falling on it, they will be reflected, right? So this will be reflected in this direction, this will be reflected in this direction, this will be reflected in this direction. Now what happens? In case the reflecting surface is smooth and well polished, the parallel rays of light, remember these are parallel rays of light, rather the incident rays, are reflected parallel to each other. That is, I can say they are reflected parallel to each other and in one particular direction, right? This type of reflection is called the regular reflection. So when this reflecting surface is smooth and well polished, the parallel rays falling on it are reflecting parallel to each other. That is, I can say they are reflected in one particular direction, and this type of reflection is called the regular reflection or specular reflection as well. So that is why for regular reflection we use the ordinary plane mirror. How a plane mirror is made? By depositing a thin layer of silver. ये तो आपने पढ़ा होगा previous classes में. So ordinary plane mirror is made by depositing a thin layer of silver on it, and the silver is then protected by a red paint, right? Because silver easily gets scratched and soon its surface may become rough. That's why it is protected by a red paint. So why silver? Because remember, silver is one of the best reflectors of light, and almost 95% of light is reflected back by the silver. That is why ordinary plane mirrors are used. That is why ordinary plane mirrors are made by depositing a thin layer of silver on it. So this will be the opaque surface of an ordinary mirror, and this will be the reflecting surface of a plane mirror, and usually we use plane mirror for regular reflection, right? Now let us discuss the second type of the reflection, that is called the irregular reflection. Irregular reflection, or we call it diffused reflection, or sometimes we may call it the scattering of light as well. So now what is irregular reflection? In case the reflecting surface is not smooth, if the reflecting surface is not smooth and well polished, the reflecting surface, if it is rough, Now what will happen if again the rays of light fall on it parallel to one another? They will not be reflected parallel. This will be reflected in this direction, this will be reflected in this direction, and this will be reflected in this direction. So when the reflecting surface is rough, the parallel rays falling on it are reflected not parallel to each other but in different directions. This type of reflection is called the irregular reflection, or we also call it the diffused reflection, or sometimes we call it the scattering as well. So this is the irregular reflection or diffused reflection. Now dear students, can you tell me which type of the reflection is more common in our day-to-day life? Since the objects we come across are usually the rough surfaces, like we have clothes, we have the chair, we have table, we have book. Usually these objects are rough, so irregular reflection is more common. That is why any object in a room can be seen from all parts of the room. Can you tell me the reason? Any object placed in a room can be seen from all sides, can be seen from all parts of the room, only because of the irregular reflection, but because that reflects light in different directions, not in a particular direction. That is why I said irregular reflection is more common, right? So these are two types of the reflection. One was irregular, regular reflection, and another was irregular reflection, right? Now let us discuss reflection of light through a plane mirror, and then we will discuss the laws of reflection, right? So let me write here reflection of light through a plane mirror. Reflection of light by a plane mirror. Reflection of light by a plane mirror, and then I will come to the laws of reflection, right? Now for this, let me take a plane mirror. You know the composition of the plane mirror, and in a ray diagram it is represented by this. This is the bake surface, rather the opaque surface of a plane mirror, and this surface is the reflecting surface. So let me name it M dash. It is the plane mirror, right? I have to discuss the laws of reflection. Now the ray of light which falls on the plane mirror, you already know its terminology from the previous classes. This is called the incident ray, right? You are familiar with the terminology. And the point, let me name this AO, and the point where it strikes the plane mirror, this point is called the point of incidence. आपको याद होगा, this is point of incidence, right? Now what will happen? This ray of light will be sent back because regular reflection will take place. So this will be sent back. This ray of light which is sent back by the plane mirror, let me call it OB. So this is called the reflected ray. So this is the reflected ray. This is point of incidence, and at the point of incidence I can draw a perpendicular to a plane mirror. So let me draw a perpendicular, let me call it ON, which is called the normal, perpendicular to the plane mirror at the point of incidence, right? So this is incident ray, point of incidence, reflected ray, and a perpendicular drawn to the plane mirror at the point of incidence, that is called the normal, right? Now let us define angle of incidence. You already know it. This angle which the incident ray makes with the normal, not this angle, this is basically called the glancing angle. The incident ray, the angle which the incident ray makes with the normal, that is called the angle of incidence. So this is angle of incidence, and the angle which the reflected ray makes with the normal, that is called the angle of reflection, usually denoted by R. So this angle is the angle of reflection, right? So you know the terminology now. The incident ray, point of incidence, reflected ray, normal, angle of incidence, angle of reflection, and the angle, remember dear students, which the incident ray makes with the plane mirror, not with the normal. This is called the glancing angle, right? So this is the terminology regarding this. Now let us discuss the laws of reflection related to the spherical and plane mirrors. Now laws of reflection. So in case of reflection, we have usually three laws there. Law first is, you can easily see, incident ray, reflected ray, and the normal. Normal is not the ray, it is just a line drawn perpendicular to the plane mirror at the point of incidence. Incident ray, reflected ray, and the normal at the point of incidence all lie in the same plane, that is, they are coplanar. Right now I have drawn this incident ray on the plane of board, so this reflected ray must lie in the plane of board, right? So this is basically the first law of reflection. The incident ray, reflected ray, and the normal at the point of incidence, they all lie in the same plane, that is, they are coplanar. Here the ray AO, OB, and ON lie in the plane of board, so they are coplanar. This is the first law of reflection. So the incident ray, reflected ray, and the normal at the point of incidence, they are coplanar, right? Now law second is, angle of incidence is always equal to angle of reflection. बात समझ आ रही है ना? और angle R is always equal to angle I. So for example, if angle I is equal to 60 degree, angle R is also equal to 60 degree. If angle I is 45 degree, angle R is also equal to 45 degree. So angle of incidence, rather angle of incidence is always equal to the angle of reflection, right? And the third law in case of this reflection is that on reflection, since the reflected ray again lies in the same medium, so its velocity will not change, frequency will also not change. Now as we know the relation velocity of wave, it is equal to nu into lambda. Nu is the frequency, lambda is the wavelength associated with a wave. Now when the velocity of the reflected ray does not change, frequency also does not change, so the wavelength also does not change. So on reflection, velocity, wavelength, and frequency of light does not change. So on reflection, the wavelength, velocity, and frequency of the reflected ray does not change, but what changes is the intensity, or I can say is the amplitude of the reflected ray, and the intensity or the amplitude of the reflected ray is always less than that of the incident ray. So these are the three laws of reflection. Now let us discuss one more special case related to the reflection. Now the question is, if a ray of light, for example, this is a plane mirror, right? You know the terminology. Now, if a ray of light falls on the plane mirror normally, can you tell me what is the angle of incidence here? Yes, it is 0 degree. A ray of light strikes the plane mirror normally, so angle of incidence here is equal to 0 degree. Now, as per the second law of reflection, angle R must be equal to 0 degree because angle I is always equal to angle R. So a ray of light must retrace its path on reflection. If a ray of light is incident on a plane mirror normally, it will retrace its path on reflection. Why? Because angle I is equal to angle R, it is equal to 0 degree. This is called the normal incidence. So in case of normal incidence, where a ray of light strikes the plane mirror normally, the reflected ray will retrace its path on reflection. This is the normal incidence in case of a plane mirror. Now let us discuss few characteristics of image formed by a plane mirror and few characteristics of the plane mirror as well. Now let me write here characteristics of image. So let me write here characteristics of image, formed by a plane mirror. Characteristics of image formed by a plane mirror. From your previous classes, you already know image is nothing but the optical appearance of an object, and we have two types of the images, real image as well as the virtual image. You are already familiar with the terminology, rather real image and virtual image. Now let us discuss few characteristics of image formed by a plane mirror. Now let me take a plane mirror here, and I can have an extended object as well as the point object, right? So for the sake of convenience here, I will take an extended object. Let me represent it by AB. Suppose this is A, this is the B, it is an extended object, and its optical appearance in the mirror, it will be called the image, right? Now let us discuss. Now this ray of light, this is incident ray, it will retrace its path as per the special case angle I equal to angle R equal to 0 degree. Now what will happen if a ray of light is falls on the plane mirror, it will be reflected in this direction. Suppose this is normal as per the laws of reflection, because angle I is equal to angle R here. Now let us proceed these reflected rays backwards, so they meet at a point. So this point will be called the B dash. This is the, I will say, virtual image of B. Why virtual? Because it cannot be obtained on the screen. Now same thing will happen here. This is the base of an extended object. It strikes the plane mirror normally. It will again retrace its path. Now if it strikes the mirror here, it will be reflected in this very direction as per the laws of reflection. बात समझ आ रही है ना? Again I can proceed these two backwards, so they meet at this very point. This will be called the A dash, which is the virtual image of A. Now same thing will happen here. For example, if it is C here, its virtual image will be formed here, C dash. Now if I join them, I will get this very image, A dash, B dash, which is the virtual image of this extended object AB. Now the characteristics of the image formed by a plane mirror are basically, the image formed by a plane mirror is virtual. Why virtual? Because it cannot be obtained on the screen, because light rays actually do not pass through the plane mirror, because this is the opaque surface of the plane mirror, this is the reflecting surface of the plane mirror. So that is why image formed by a plane mirror is virtual, because it cannot be obtained on screen. That is why I have shown this by dotted lines. Light rays actually don't pass through this, right? So image formed by a plane mirror is virtual. Now you can see image formed by a plane mirror is erect. Now you can see it is B, it is B dash, it is A, it is A dash. So what does erect mean? It means same side up here. Now see, AB, rather height of the object, it is equal to height of the image, which we can verify experimentally as well, and you can see it from the diagram as well. So height of the object, it is equal to height of image, rather I can say size of object is equal to size of image. So in case of a plane mirror, linear magnification, which we define by h2 by h1, so it is equal to 1, rather I will say plus 1 if I use the new Cartesian sign conventions. Why plus? Because image formed is virtual and erect, and why 1? Because size of image is equal to the size of object, as h1 is equal to h2. So 1 means size of image is equal to size of object, and plus sign indicates that image is formed above the principal axis, right? So it is virtual and erect here. Now one more point regarding the image here is that if AB, the distance of the object from plane mirror, let me denote it by U, that is the objective distance, and the distance of image from mirror, it will be denoted by V, that is the image distance. Now you can see it and we can verify it experimentally as well. Objective distance is equal to image distance. I mean, the image formed by a plane mirror is as far behind the mirror as the object is in front of it. That is object distance U, it is equal to image distance. For example, if an object is at a distance of 5 meter from the mirror, then its image will be formed at a distance of 5 meter from the mirror. Now the question is, what is the distance of image from the object? It will be 5 plus 5, that is 10 meters, right? Now one thing more, if I place, let me extend this mirror here. Suppose this is also a plane mirror. If I write R here, what will be its image? It will be like this, Have you seen this? What is this phenomenon called? This is called the lateral inversion, and this image is called the laterally inverted image. So this is called the lateral inversion. What does lateral inversion mean? When the right side of the object becomes the left side of image, and vice versa, I can see. When the left side of the object becomes the right side of an image, that phenomenon is called the lateral inversion or sideways inversion. Like if it is read like this RED, so its laterally inverted image will be like this. You might have seen the word ambulance written like this. That is the laterally inverted image of ambulance. So we can read that word ambulance in a nice way by using the driver's mirror, that is usually a convex mirror. So this is the lateral inversion in case of the plane mirror. Now characteristics of image formed by a plane mirror and the characteristics of this plane mirror. Suppose this is an object, right, and this is a fixed plane mirror here, and this will be the virtual image of this very object. Now if I keep the plane mirror fixed and if I displace this object towards or away from the plane mirror by a distance x, बात समझ आ रही है ना? If an object is moved by towards or away from the plane mirror by a distance x, what will happen? Its virtual image will also move towards or away from the plane mirror by the same distance x. बात समझ आ रही है ना? And same is the case with the velocity as well. If an object moves with a velocity v towards a fixed plane mirror, its image will also move towards the mirror with the same velocity v. Now the question is, what is the relative velocity of image with respect to object? ये जो concept है relative velocity का 11th में आपने पढ़ा होगा. When the two bodies move in opposite direction, their velocity, relative velocity gets added. So this is v plus v, that is equal to 2v. That is the relative velocity of image with respect to object. So when an object moves with a velocity v towards a fixed plane mirror, its image will also move towards the mirror with the same velocity v, but the relative velocity of image with respect to object, it will be v plus v, that is equal to 2v, right? Now what will happen when two plane mirrors are inclined at an angle? Suppose this is one plane mirror, बात समझ आ रही है ना? This is another plane mirror, and suppose they are inclined at an angle theta, and an object is placed in between them. Suppose this is an object O which is placed between two inclined mirrors. Now what will happen? Because of the successive reflections, because of the multiple reflections, number of images will be formed because of successive reflections. But remember, dear students, the distant images will become fainter and fainter. Why? Because their brightness will decrease. Why? Can you tell me the reason? Because some part of light energy is absorbed during each and every reflection. That is why we are not able to see the distant images in the plane mirrors. Now the case is, when two plane mirrors are inclined at an angle theta, the number of images formed will be, it will depend upon this, 360 by theta minus 1. Remember, dear students, if 360 by theta is even, बात समझ आ रही है ना? First of all, we will calculate 360 by theta. If it is even, then the number of images formed is 360 by theta minus 1, and if it is odd, then the number of images formed is 360 by theta if 360 by theta is odd. So if it is odd, then the number of images is simply 360 by theta. Let me elaborate it with the help of an example. If theta is equal to, for example, let it be 60 degree, how many images will be formed? This is 360 by 60 degree. First of all, we will calculate 360 by 60. So this is 6. 6 is even rather. So the number of images formed is 6 minus 1. That is 5 images will be formed in case the two plane mirrors are inclined at an angle of 60 degree. Now what will happen if the two plane mirrors are inclined, for example, at an angle of 24 degree? Now first of all, we will calculate 360 by theta. So this is 3 360 divided by 24. So this is 15. So 15 is odd, so it will remain as it is. So 15 images will be formed in case the two plane mirrors are inclined at an angle of 24 degree. So dear students, let me revise the things which we discussed in today's lecture. I started from the definition of the light, then two facts about light, then nature of the light. Right now you know light possesses dual nature, particle nature as well as the wave nature. Different theories regarding the nature of the light, you right now know them. Then brief review about the light. After this we discussed the first property of the light, that is reflection of the light. Simply sending back of light, bouncing back of light, or change in the path of light without any change in medium. Then we discussed a little bit about the plane mirror, then the laws of reflection. Right now you know three laws of reflection, and remember dear students, these three laws of reflection, they are equally applicable to all kinds of mirrors, be the mirror plane mirror, spherical mirrors, concave mirror or convex mirror, as well as the parabolic mirrors as well. After laws of reflection we discussed the image formation by a plane mirror, and in the end we discussed the characteristics of image formed by a plane mirror. So image formed by a plane mirror is virtual, it is erect, size of image is equal to the size of object, and the linear magnification produced by a plane mirror is +1. You know the physical significance of it as well. And objective distance is equal to image distance, and the image formed by a plane mirror is laterally inverted, that is sideways reversed. Then we discussed how many images will be formed if the two plane mirrors are inclined at an angle theta. This will depend upon the angle of inclination. If 360 by theta is even, then the number of images formed will be 360 by theta minus 1. If it is odd, then the number of images formed will be 360 by theta. And we also discussed what will happen to the objective distance and image distance, objective velocity and image velocity in case a plane mirror is fixed and object is moved towards or away from the plane mirror, right? So dear students, remember two more characteristics of the plane mirror as well. You know one, magnification produced by a plane mirror is +1, focal length and radius of curvature of a plane mirror is infinite, and power, that is the reciprocal of the focal length, and it is 0 in case of a plane mirror. So this is what we discussed in today's lecture. So this is all for today's lecture. We'll be meeting in the next lectures. Till then, goodbye.